So the focus for the sequence applications, at least for these sets of examples, are to do with money, although recursive sequences you can apply in a number of different contexts, not just money, but that's what we're going to start with today. You will notice that in some questions we might talk about initial values, we might talk about values after a certain number of years, and so you do need to be considerate as to what your starting term might be when we set up and then try to generate a sequence. Now, when the numbers aren't particularly nice, then usually it is a calc assumed problem that you are dealing with. Although in last year's ATAR exam, there was a question in the Calc 3 where students had to solve an equation. It was a linear one that related to a type of sequence. It was what we call an arithmetic sequence. So don't expect everything always to be in the calc assumed. In this scenario, if you have a look, it is quite nice how we link year with salary, year 2 with salary, year 3 with salary, and so forth. And so when we talk about the first year salary in the first year, we can then refer that to term 1. So that is really helpful, and it will be obvious when I talk about term 0 when we come up to it. So here, this is your first term, that's your second, that's your third, that's your fourth, and there's a pattern connecting those numbers. Can anyone tell me what that pattern might be? What's happening each time to the salary? Yeah, it's adding 750 each time. So going up by 750, don't assume that that is necessarily going to be the case where you're adding. It could be, often salaries increase by a certain percentage actually. Maybe not necessarily consistent, but in the context of these problems it would have to be. Okay, at least for some years. So what would be the salary in the 5th year? So if we had to keep going, what would the salary be? 38,000. The first order recursive rule representing this information, in other words, just give me the recursive rule, don't worry about that fancy terminology. Remember, we start to get the next term, Tn plus 1, what are we doing? We are adding 750. What's missing here? Yes, T1. So how much would someone earn in their 9th year and then the total over 10 years? You can keep going and keep adding 750 if you want, or if you recall from last time I saw you, we did set up some sequences in the sequence app on the calculator. So in this case, it would be AN plus 750. Starting term was 35,000, and then you can call up your sequence. Now we are interested in the 9th year, so you do need to scroll down to 9. So remember, I set this calculator up to 20 the other day, so it's still there. Default, it's not the default setting. Default is 1 to 5, but if you haven't changed your settings, it should be the same as last time. So 41,000 in their 9th year, and then over a total of 10 years. Then remember the sum column next to that sequence. So that would be 383,750. So straight off the calculator, reading that information. If we have a scenario where we need to talk about a starting value, so not in the first year, but at the start, initial. So usually the word initial or at the start or something like that at the beginning is when we would often then recognise that we need an initial value, and we would use T0 as opposed to T1. So for example, if we look at this one, we've got talking about school fees. The school fees have increased by 6% each year. 2010 is 2,400 was the school fee. So Tn plus 1 how would we represent a 6% increase? What would we have to do to the previous term to show that? An increase, and we want the final school fees. How much you're going to pay with that 6% increase? What do we have to multiply TN by? Yeah, 1.06. Now, this question is talking about T0. And we might use T0, we might use T1 here. You could write this as T1. The advantage of using T0 is that 0 matches 2010. Well, that's one advantage. But this is not an obvious question where it is necessarily needs an initial value. However, if we want to talk about the scenario, then I would be actually using T0 because it links nicely to that 2010 tuition fee. If you're not sure, then you can actually write the year and the term number. And I'll show you what I mean by that in the next one. So 2015. So 2010, I've suggested to use term 0. Then 2011 would be term 1. And you can see how that works quite nicely. Term 2, term 3, term 4, and term 5 for 2015. So if we started with term 1 at 2010, then 2011 would be term 2, 2012 would be term 3, and so forth. We'd be looking at term 6 for 2016, 15, not 16. So you can see that there could be a confusion with those numbers. So using term 0 is quite nice because it matches with term 2010. It doesn't make a difference. You're still going to generate the same numbers in sequence order. It's just the position number that may get a little confusing. So, because I mentioned term 0, how do we change the sequence to term 0? You need to tap on, make sure you've tapped onto the sequence equation part of the screen, not the table, and then go to type on the calculator, go to type, go back and change it to A0, and then put in what we want. So this is times 1.06, and the initial school fees were 2,400, and then you can generate the sequence. So after 1 year, it's going to be 2,544 and so forth, and we want it in 2015. Now, if we tap on that part of the table, the actual figure will come up at the bottom. So you can see the 0.74. Don't just write 0.7. You do need to get in the habit of being quite exact with these sequences. So 3,211.74, and I can tell that from the bottom of the table there. In which year will it first exceed 4,000? So we just scroll down and look, and there it is. Term 9, which links to 2019. And then you've got a student attends school from year 1 to year 6 beginning in 2010. What will be the total amount paid for their primary school years? So given my sequence, 2010 term 0 is year 1. So this is where it gets confusing. Term 1 would be year 2. T1 would be year 2, which is 2011. So year 6 would be 2015. So we want the sum from term 0 to term 5. So back on the calculator, reading off the sum, and that would be 16,740.76. So had you used term 1, so I'm going to go back, change the type to term 1. you would still get that same figure. Except it's not 35,000, that's why that wasn't working. You would still get that same or those same figures. And there's your sum. But you would sum from term 1 to term 6, not term 0 to term 5. So it just depends on that starting value, how the sequence has been numbered. So that wasn't a particularly good one in terms of using term 0, but helpful to match 2010, not helpful to match the year grade number. So either or there. This one might be better. So that 0.058 on 12 is the monthly rate. So what happens each month is you're going to increase. So just like the previous question where we had to do 1.06, this is the same thing, but like I said, that's not a nice number at all. So we don't want to be writing 1.0483 because then where do you stop? How many threes do you do? Or do you do any threes? You should do it be as exact as possible. So if we do it like this, where it's showing the monthly increase as your percentage rate, that's your rate plus the increase, and it will be whatever the previous term was, and then your initial investment was the 35,000. I'm just going to move that out the way. So just want to show you how that works and how the sequence is then generated.
To 3 because it's 3 years?
No, because this is a recursive rule, so we just want to see what's going on each month.
Oh, I see.
You don't want the final, that would just give you a final answer.
Okay, that makes sense then.
So if we go back into sequence, and this time we want this as 1 plus 0.058 over 12, and then the starting value, we'll make this an A0 type. Don't want that. Yep. The starting value is 35,000. You didn't like me going backwards. Let's just put that back in. So 1 plus 0.058 over 12. So what this is going to generate, that 0.058 is the monthly rates. Add to 1 gives you that increase. It's going to generate what it's worth after every single month. That's what we're about to find here, with an initial value of 35,000. So it starts at 35 after 1 month. Why hasn't that come up? So you can see here after 1 month, the investment is worth $35,169.17. So in that first month, they've earned $169.17 interest. In the next month, it will be worth more, and then keep going, obviously. And it's compounding. It's got that compounding effect. So when you use your compound interest formula, it will give you a figure and what it's worth at the very end of the time period. What this does, being able to generate this recursively, allows you to see how things are progressing every single month. And we want this monthly for 3 years. So ideally, our table should go from 1 to 36, because there's 36 months in 3 years. And then you'll see at the very end, that is what the investment is worth. 41,634 and 49. Now that's probably going back into, I'm just writing this down because I have to type in another sequence in a minute. Okay, so that's compounded monthly. So I want you to now replicate that same idea, but in option B, we are compounding fortnightly. What would the recursive rule look like? It's not ideal because there are slightly more than 26 fortnights in a year, but let's not go there. So this shows you the exact percentage increase per fortnight. So still starting at 35,000. Now, this time we have a second sequence. We might need to refer back to the first sequence. So what do you think might be a good idea here? Put it into the next one, put it in B. Yeah. But be very careful. If you're putting in B, you've got to use BN, not AN, because it will let you put AN if you want. So be careful. So use BN, not AN. And the initial is back at 35. Now, if you leave the first one on, you'll lose the sum. Oh, no, you won't. You'll have the sum, the sequence and the sum. You just need to arrow across. It is better to compare without the sum. So I'm going to omit my sum display off, because I want to compare these two sequences. Okay, so I haven't got a sum display anymore, so I can compare. So you've got to remember though that sequence number 2 is fortnightly, sequence number 1 is monthly. So at the end of the first year, which is the better investment? Well, the blue one needs to go for 12 months. So that is the first investment, A. After 12 months, it's worth that much. Whereas the second sequence, we've got to go down to 26 fortnights. So 36, 9, 39, 89. So sequence B. And this was term 12. So just be careful. It's, even though you're comparing two sequences, one is at monthly, one is fortnightly. But basically, at the end of the year, you've got a slightly better investment for A. But that's at the end of 1 year. I suspect he wants to put it away. It says for 2.5 years. Where did we get 3 years from? Oh, okay, this is it here. 3 years, 4 years. So that time allocation is not helpful for the final part to this question. He wants to put it in a term deposit for 2.5 years. Which option should he choose? Well, actually, neither option is relevant, but let's assume that we are now doing 2.5 years at the same rate. The first option, A, 2.5 years, how many months is that going to be? 12 months a year, 12, 24 plus another 6 makes 30. So in option A, it's 30 months. So we want to see what the figure is at T30, not the one that I wrote down before. For option B, 2.5 years, how many fortnights is that? 52, 65. So back to our sequence, we want term 30 for sequence A, 44, 4, 7, 25. We want 65 fortnights. Now, I've only done my table up to 36. If I tap on the equation screen, I can go back in and change my table. I don't want to start from 1, otherwise I'm going to be scrolling down forever. I know it's 65 fortnights, so I'm just going to go from 60 to 66. That'll do. And now call up the table. And there we are. 65 fortnights, 40,053 and 18. So the best investment, or the one that's going to give him the most, assuming there's exactly 26 fortnights in a year, will be the first one. And that's because it certainly has a better rate. Even though the more often you compound, the more interest you accrue. That 5.4 is clearly not enough of a too much of a difference. If I change that to a 6, for example, just out of interest, just want to show you, after 65 fortnights, we get 40,254. You don't need to write this down. And then if we go back, set up my table, I need 30 months. So I'm going to go from 25 to 30 for sequence A. At the end of 30 months, sequence A is 40. Oh no, it's still better. So still better. So it's too short an amount of time. Anyway, that was more for interest for me to see what was going on, but still not much of a change. Okay, so in this case here, having T0 as the initial is certainly advantageous, because each time we add a increment in our sequence number, that links to the number, the time period. So if it's 1, T1 is 1 month or 1 fortnight after. T2 would be 2 months after, or 2 fortnights, depending on whether we're using sequence A or sequence B.